Hi everyone! In this lesson, we will go over the definition and usage of mean absolute deviation. So mean absolute deviation can be abbreviated as MAD, MAD. It means the average distance of all of the data values in the dataset from the mean of the distribution. To find the MAD is basically doing the mean twice. Now the MAD helps to describe the variability of a dataset just like the IQR. If the MAD is a large value, it means that the dataset is more spread out and that the mean is not a relevant description of the dataset. If the MAD is a small value, it means that the data points are more clustered together and the mean is a relevant description of the dataset. The following are the steps to find the mean absolute deviation. First, find the mean or average of the dataset. Then find the distance of each value from the mean. Since distance has to be positive, it has to be the absolute value of the distance of each point to the mean. The last step is to find the average again, but with the distance values. We will try out two examples right now. The first example asks us to find the MAD of the dataset that shows the number of contacts 8 friends have stored in each of their cell phone. Let's begin by finding the mean of the dataset first. The 8 numbers add up to 448, so 448 divided by 8 is 56. As a reminder, we are dividing by 8 because there are 8 numbers on the list. Now, let's find the difference of each data point from 56, the mean. For this example, let's do it by placing each number on a line plot. On the left side of the mean, 48 is 8 units from 56. 52 is 4 units from 56, 54 is 2 units from 56, and 55 is 1 unit from 56. On the right side of the mean, 58 is 2 units from 56, 59 is 3 units from 56, 60 is 4 units from 56, and 62 is 6 units from 56. The last step is to find the average of all these numbers, which they add up to 30, and 30 divided by 8 is 3.75. So to wrap this up, let's fill in the blanks below. The MAD for the numbers of contacts stored is 3.75. Since it is a small value, it means that on average, the number of contacts stored in a cell phone is about 4 more or 4 less than the mean, which is 56 contacts. A small MAD also means that the average is a good representation of the dataset, as it shows that there is a small discrepancy amongst the dataset. In the second example, we are asked to find the MAD of 2 datasets and compare them. Example 2 says that the table shows the amount of money raised by the 6th and the 7th grades. Find the mean absolute deviation for each set of data, round to the nearest hundredth, then write a few sentences comparing their variation. Let's begin with the 6th grade dataset. We will first find the mean of the 6 data values, which the 6 numbers add up to 642, and 642 divided by 6 is $107. Now, we need to find the distance of each number from the average. 88 is 19 away from 107, 94 is 13 away from 107, and so on. Once we get the 6 distances, we need to average them together, which will bring us $10.67 as our MAD. For the 7th grade dataset, let's begin by finding the mean of the 6 values as well, which is $119. For this last question, let's find the distance of each number from the mean by using the absolute value number sentences. The absolute value of 91 minus 119 is 28, as the absolute value of a number is always positive. The absolute value of 97 minus 119 is 22, and so on. The last step is to add these numbers together and divide it by 6 to find the average, which is $16.67. Now let's compare the 2 datasets by filling in the blanks below. The MAD for 6th grade is $10.67 and the MAD for the 7th grade is $16.67. Since the 7th grade has a higher math, the money raised by the 7th grade is more spread out than the 6th grade. Since the 6th grade has a smaller math, the data values from the 6th grade is closer to the mean than the 7th grade, as a smaller math indicates that the data values are more clustered together. Okay, that's it for the lesson.